All right, we are moving into Module 6 and Lesson 1 on Module 6, which is on modeling linear relationships. So we're not just leaving the functions and the equations, the linear equation working on, we're not just leaving those behind. We're going to dive deeper into understanding them, okay? So again, think of linear relationships, right? There's going to be a relationship between two quantities, x's and y's. In this case, linear means our graph's going to be a straight line. It also means there's something we're multiplying by. There's a constant. Okay, so again, we're not leaving behind what we've been working on. We're diving deeper into it. So Lenore just purchased a tablet computer and she considered purchasing an internet access plan so she can connect virtually anywhere in the world. So one company offers a plan so when a person connects to the company's wireless network, they're charged a fixed access fee plus an amount for the number of minutes connected based on constant usage rate in dollars per minute. Okay, so we're going to pay something per minute plus a fee. So she's considering it, but they don't tell us what the fee is. That's what it says here. It doesn't say what the fee is or what the rate is. But we're going to see if we can figure it out because they say that a 10-minute session costs 40 cents, a 20-minute session costs 70, a 30-minute session costs $1. Okay, so we're going to use these pieces, like Lenore did here, to determine both the fixed access fee, the amount we're starting with, even if we use 0 minutes, and the usage rate. So this stuff is going to be really wordy. So a lot of times it's easy when we have these real world problems with all these words to pull out the information and put it in a table or a graph. Then we're looking, it's not all the extra stuff. We're looking at just what we need to know. So it says Lenore makes a table of this information right here. Okay. This is what is coming from up top here. 10 minutes costs 40 cents, 20 minutes cost 70 cents, 30 minutes costs $1. And it says, makes a table and a graph where the x-axis is the number of minutes. That's really, really common, right? We're going to put our independent variable, our excuse me, our time is going to lie on the x-axis, and the y is going to be the cost. Plot the 3 given points in the graph. All right, we can do that. Because remember, these are x values, these are y. So these 3 that we know here, at 10 minutes, she was at 40 cents. Okay, so here's 0, here's 50 cents, here's $1. So 40 cents is just going to be like right in here, okay? So we can't make it exact because of the scale we have here, but we do our best to put it where we think it should be. 20 is at 70, so halfway between 0.5 and 1 would be 0.75, so it's going to be just underneath that. And then we have 30 is at $1. Good. That one's easy, right through the grid lines. Okay? These points appear to lie in a line. Yeah, they do. What information about the access plan suggests that the correct model is indeed a linear relationship? Okay, so and we're going to come back to this graph. We're going to keep adding things. But what information suggests that this linear relationship? Okay, so first of all, we're going to say points appear to be a straight line. Okay, that's the first giveaway, right? Can't tell exactly because, again, we're approximating. Something else. We are right here. Remember, we are at 0.40, right? 0.4. And then we went up to 0.7. Sorry, I'm writing so small and it's messy here. Okay, so we're going 0.4 to 0.7. We're going up 30 cents, right? So this is up 30 cents from 40 cents to 70 cents. And over, notice we're going over 10 units, right? So let's see if that's constant, because to be linear, we need to be constant, right? So if I go from 0.7 to 1, that's another 3/10 up, 30 cents up. And we're going over another 10 minutes. So I would also say that the rate of change, how much is changing, how much something is changing as we move along the graph, another word for our slope, remember, I could figure out exactly here, appears to be 30, not 30. Not straight up 30. Appears to be 30 cents, right? 0.3, 3/10, 30 cents per 10 minutes. Okay, and I could figure that unit rate out, but what we're saying is it appears that we're moving at the same rate. We're multiplying by the same number every single time. Okay, so that information suggests we have a constant and it appears to be a straight line, that it's linear. All right, so we're going to keep scrolling back and forth here. The rate of change describes the total cost with respect to time. When the number of minutes increases by 10 minutes to 20 minutes, 20 minutes to 30 minutes, how much does the charge increase? Well, that's what we just did there, right? As we go over 10 minutes, it's going up 30 cents each time, okay? So we'll just say 30 cents. How much does the charge increase? 30 cents. And I'm just going to add here per 10 minutes. Because it's not 30 cents per minute, it's 30 cents per 10 minutes. So another way to say this would be the usage charge per 10 minutes of use, okay? So the charge is per every 10 minutes of use. Use that information to determine the increase in cost based on only 1 minute of additional usage. In other words, find the charge per minute, unit rate. Okay, so remember our unit rate. If we know the cost per 10 minutes, and I want to know what it is per 1 minute, well, remember, what do I do to 10 to get 1? Divide by 10, right? So what am I going to do to 30 cents? I'm going to divide by 10. We've done this before. We found unit rates. Hey, it's great that's per 10 minutes, but I want to figure out 1 minute, so I'm just going to divide by 10. Don't overthink it. Remember what I said. This isn't brand new stuff. We're diving deeper into understanding. So if I take 30 cents, 3/10, 30 hundredths, however, and I divide it by 10, just grab a calculator, divide it by 10, that gives me 0.03. So it looks like we're paying 3 cents per minute. This is the unit rate. Not unite. Unit rate. Okay? All right. So on the graph, draw a line through the points representing 0 to 60 minutes of use of this company's plan. Okay? The slope of the line is equal to the rate of change. Okay, so basically, let's draw a line and fill in the rest of our table. Okay? So I'm going to grab a straight edge here. Okay? And I am going to stop for a second. Oh, no, I'm not. I'm going to just dive right in. Okay? And I'm going to make sure that it makes sense. Now, we need to extend it in both directions. Okay. And I'm going to do the best I can to get it through the points. Okay. And the reason I hesitate a little bit is because I wanted to put it through 0, 0, right? I'm like, hey, if we're not doing any minutes, we're not charging anything. But remember, up top here, it said we're paying a fixed access fee plus some change per minute. Okay. So when I draw this line in here, I can see that we're going to be charging something. Okay. So there's my line. Okay. And if we go up 30 cents each time, right? If I'm at 1 and I go up 30 cents, okay, I'm going to be at 40 minutes at $1.30. If I at $1.30 and I go up another 30 cents and over, and we're going to do this with equation here in a second. Maybe I'll leave that first and last one blank here. But that's going to be, notice, 1 minute and 60 seconds. All right, so the very last thing we have to do, okay, is using X for the number of minutes and Y for the total cost, write a function. All right, this, our best friend here, right? Y equals mx plus b. Remember, m is our slope or our unit rate, or our rate of change. I don't have to figure it out. I know what that is. Okay? Y equals 0.03. right? That's what we figured out here, unit rate, times x plus, remember our b here is our initial value. Now we could absolutely figure this out plugging in what we know, but if I go back to the table here, remember, going this way, at 50 minutes, I'm at $1.60. So if I go up 30 cents more and over 10 minutes, I'm adding another 60 cents. But it also works the other way, right? Okay, not that we read from right to left, but if I go down 30 cents in over 10 minutes, if I'm at 40 cents and I go down 30 cents, I'm at 10 cents. This right here is our initial value, right? Where our number of minutes is 0. So this is initial value, and it's our y-intercept. Okay, so I don't have to figure anything out. I know it's 10 cents. In this way, now that I have my function, my linear function, I can say between minutes of use and total cost, my cost equals 3 cents times the number of minutes plus 10 cents.